Chapter 5 Acids, Bases and Salts. Class 7th. Different food items taste different. Some are sweet in taste, some are salty, some are sour, while some are bitter. Have you ever wondered what makes some substance bitter or sour? Let us find out. Acids: lemon, curd, amla, tamarind, and orange juice taste sour. These substances contain acids that give them the sour taste. The word acid comes from the Latin word acidus, which means sour. The substances that contain acids are said to be acidic in nature. All sour fruits are acidic in nature. Different things contain different types of acids. Types of acids. Acids are commonly grouped as organic acids and inorganic acids. Organic acids. Some acids contain naturally in plants and animals. They are called organic acids. All organic acids contain carbon and hydrogen atoms. Some common examples of organic acids are lactic acid, acetic acid, formic acid, citric acid, oxalic acid, and uric acid. Organic acids are weak acids. Mineral acids. These acids are derived from mineral resources. Sulfuric acid, hydrochloric acid, and nitric acid are commonly used mineral acids. Mineral acids contain at least one hydrogen atom but no carbon atom. They are commonly used in chemical laboratories. Most mineral acids are strong acids and should be handled with carefully. They can cause burn on the skin. Examples of organic acids: lemon and oranges. The acid present is citric acid. Sour milk. The acid present is lactic acid. Vinegar. Acid present is acetic acid. Grapes and tamarind. Acid present is tartaric acid. Fizzy drinks. Acid present is carbonic acid. Vitamin C. Acid present is ascorbic acid. Gastric juices. Acid present is hydrochloric acid. Urine. Acid present is uric acid. Tea. Acid present is tannic acid. Properties of acids. Following are the some of the properties of acids. Acid have sour taste. All citrus fruits taste sour due to the presence of acid in it. They are corrosive in nature. They have a tendency of damaging the surface they come in contact with, including most metals. That is why acids are not stored in metal containers. They are usually stored in glass containers. Exposure of eye, skin, acids could be dangerous. So be always careful while handling acids. They turn blue litmus red. Acids are soluble in water. Most acids dissolve in water to form a solution. If a large amount of acid is dissolved in a small amount of water, the acid is said to be concentrated. If the amount of acid is now dissolved in large amount of water, the strength of acid reduces. The acid becomes dilute. Heat is produced when strong acid is mixed in water. So, take the following precautions while diluting an acid. Never add water to an acid. Slowly add acid to water in small amounts. Constantly stir the solution. They react with certain metals to form salts and give hydrogen gas. Acid plus metal gives you salt and hydrogen gas is released. For example, a reaction between hydrochloric acid and magnesium, which leads to the formation of magnesium chloride and hydrogen gas is evolved. Metals such as sodium and potassium are also acted upon in a similar way by acids. Less reactive metals such as copper, gold, silver cannot display hydrogen from acids. Hence, these metals do not react with dilute acids. Uses of acids. Acids are quite useful compounds. The gastric juice in our stomach contain hydrochloric acid. It helps in the breakdown and digestion of food. Vitamin C, essential for a healthy body, is ascorbic acid. We often use vinegar, that is, a 4 to 6% solution of acetic acid in water, as a food preservative. Let us look at the importance of few commonly used acid in our daily life. Hydrochloric acid. It is used mainly for removing rust from iron and steel before using in various industrial processes. It is also used in the production of various compounds such as vinyl chloride and limestone, as well as in the preparation of cleaning liquids. It is also used in the refining process of common salt. It is also used in the manufacturing of chlorine and making aqua regia. Aqua regia here is 3 parts of hydrochloric acid and 1 part of nitric acid. It is used to dissolve noble metals such as gold and platinum. Sulfuric acid. It is one of the most commonly used acid. Because of its widespread use, it is called king of chemicals. It is used in car and inverter batteries. It is used in the manufacturing of fertilizers such as superphosphate and ammonium sulfate. It is used in the manufacturing of dyes, detergents, explosives, and drugs. It is used to make salts such as zinc sulfate, copper sulfate, and calcium sulfate. It is used in cleaning iron and steel before plating them with tin or zinc. It is used in the manufacturing of synthetic fiber, that is rayon. Acetic acid. It is used as a vinegar in the food preservation and to enhance flavor of food. It is also used in the manufacturing of products such as ink for textile printing, dyes, photographic chemicals, pesticides, pharmaceuticals, food preservatives, rubber, and plastics. Nitric acid. It is mainly used in the production of fertilizers such as ammonium nitrate. It is also used to make explosives, nylon, and synthetic dyes. It is also used in rocket fuel. It is also used as cleaning agent to clean stainless steel. Bases. Baking soda tastes bitter. It also feels slippery or soapy when touched. Substances like baking soda that are bitter in taste and give a slippery feel are called bases. They are often found in household cleaners, dishwashing liquids, soaps, detergent, toothpaste, and so on. Substances containing bases are said to be basic in nature. Sodium hydroxide, potassium hydroxide, ammonium hydroxide, and calcium hydroxide are a few examples of bases used in laboratories. Types of bases. Bases can also be grouped as strong and weak. Strong bases such as sodium hydroxide and potassium hydroxide are as corrosive as strong acids. They can damage tissues and burn the skin. So, one should handle them with care and should not touch them with bare hands. Copper hydroxide, zinc hydroxide, ammonium hydroxide are examples of weak bases. Properties of bases. They taste bitter. They are slippery or soapy to touch. They turn red litmus blue. They react with acid to produce salt and water. Not all bases are soluble in water. Bases that are soluble in water are called alkalis. For example, sodium hydroxide, potassium hydroxide are alkalis because they are soluble in water. Bases that are insoluble in water are not alkalis. Therefore, all alkalis are bases, but all bases are not alkalis. We use a lot of bases for our daily uses. Many bases are used extensively in industries for a variety of purposes. Calcium hydroxide. Calcium hydroxide is a strong base and is commonly called slaked lime. It is used as an important constituent in many agricultural pesticides. It is also used for neutralizing acidic soil. Excessive use of fertilizer over a period of time may lead to soil becoming acidic. Acidic soil is not good for the growth of plants. So, to neutralize the acidic soil, farmers add slaked lime, that is calcium hydroxide, to it. It is also used in whitewashing. Whitewash, an important low cost paint, has a slaked lime as the chief ingredient. It is also used for treating wastewater from factories. Wastewater from factories is highly acidic in nature. If it is released in water bodies like river, it might affect the aquatic life. So, it is usually treated with calcium hydroxide before being disposed of into the water bodies. Potassium hydroxide. Potassium hydroxide, commonly known as caustic potash. It is useful in the preparation of biodiesel. It is used in the production of disinfectants as well as liquid soaps, lotions, shampoos, and drain cleaners. Sodium hydroxide. Sodium hydroxide is a strong base commonly used or commonly called caustic soda. It is used in unclogging drains at home. It is also used in the manufacturing of paper, textiles, soaps, and detergent. Magnesium hydroxide. Magnesium hydroxide is also known as milk of magnesia. It is a wonderful antacid that works by neutralizing excessive acidity in the stomach. In the industry, it is used as a non hazardous base to neutralize acidic wastewater. Differences between acids and bases. Acids are sour in taste, and concentrated acids can cause skin burn, and care should be taken while handling acids. It turns blue litmus paper to red and also react with bases to form salt and water. That is, a neutralization reaction is taking place. Some examples are of acids are sulfuric acid, which is used in car batteries, stomach acid, that is hydrochloric acid, household vinegar, that is acetic acid, lemon juice, orange juice, or citrus fruit juices, which are considered to be citric acid. Bases. Bases are bitter in taste, and concentrated bases can cause skin burn, and care should be taken while handling the bases. Bases are often feel slippery or soapy, and bases turn red litmus paper to blue. It also reacts with acid to form salt and water. Some examples of bases are drain cleaner, oven cleaner, that is sodium hydroxide, cleaning products, that is ammonia solution, milk of magnesia, that is magnesium hydroxide, basically used as antacid. Identifying an acid from a base. Unlike food items, we cannot taste chemicals to identify acids or bases. Tasting a chemical can be highly dangerous. How do we know whether a chemical substance is acidic or basic? There are certain chemical substances known as indicators that help us to identify acids and base. Indicators. An indicator is a substance that indicate the presence of an acidic or basic solution by changing color. If there is no change in color, the solution is neither acidic nor basic. Such substances are called neutral substances. Indicators can either be natural or synthetic. Natural indicators. Many natural dyes found in fruits, vegetables, and flowers act as indicators. For example, red cabbage extract turns red in acidic solution, green or yellow in basic solution. China rose extract is also a natural indicator. It turns an acidic solution into magenta or red and basic solution into yellow or greenish yellow. Litmus is the most commonly used natural indicator. It is a dye extract from the lichens which changes its color in acidic or basic medium. Litmus solution is a solution prepared from this extract. Litmus paper is prepared by absorbing litmus on filter paper. It comes into two colors, blue and red. An acidic substance turns blue litmus paper red, a base turns a red litmus paper blue. Synthetic indicators. Phenolphthalein is a synthetic indicator which is a colorless and changes its color to magenta in a basic medium. Methyl orange is a synthetic indicator which changes its color from an orange to red in acidic medium and orange to yellow in basic medium. Let us see an activity to classify various substances as acidic, basic, and neutral. Materials required are blue and red litmus paper strips, hydrochloric acid, vinegar, calcium hydroxide, sodium hydroxide, dropper, test tubes, and distilled water. Take small quantities of hydrochloric acid, vinegar, small sodium hydroxide, distilled water, and calcium hydroxide in separate test tubes. With the help of a dropper, put a few drops of each substance on the blue and red litmus paper strips and observe. You will find that hydrochloric acid and vinegar turns blue litmus red and show no change in color of red litmus paper. Sodium hydroxide and calcium hydroxide turn red litmus blue and show no color change of blue litmus paper. Distilled water shows no change in color of red and blue litmus papers. Conclusion. It can be concluded that hydrochloric acid and vinegar are acidic substances. Sodium hydroxide and calcium hydroxide are basic, while water is neutral substance. Activity to prepare some natural indicators. Materials required: China rose petals, water, beaker, tripod stand, wire gauge, Bunsen burner, funnel, filter paper, vinegar, and lime water. Procedure involved: take water in the beaker and add rose petals to it.
Heat the beaker for 10 to 15 minutes, filter the extract, add it to vinegar and lime water. Record your observations. Observations. You will find that extracts appear pink when added to dilute hydrochloric acid. It changes to magenta. On adding it to lime water, it turns green. This indicates that vinegar is an acid and lime water is a base, because the China rose extract turns magenta in acid and green in bases.
Salts. Salts are substances formed when an acid reacts with base. The reaction is called neutralization reaction. Water is also produced in this reaction. For example, sodium chloride, known as table salt, is the most common salt known to us. It can be prepared in the laboratory by reaction between sodium hydroxide and hydrochloric acid. This reaction is represented by the following reaction. Acid plus base gives you salt and water. Hydrochloric acid plus sodium hydroxide gives you sodium chloride and water. In such a reaction, hydrogen in the acid is displaced by the metal, that is sodium, from the base to form a salt. Salt can also be prepared by reaction between an acid and a metal. In such reaction, hydrogen gas is produced along with the salt. For example, hydrochloric acid reacting with magnesium, giving you magnesium chloride, and hydrogen gas is evolved. Let us see an activity to make an insoluble salt by reducing an acid with a metal. Materials required: a test tube, matchbox, zinc powder, hydrochloric acid, and hand gloves. Procedure: wear your gloves, pour the acid into the test tube and add zinc powder to it. The acid and the metal react to produce salt, zinc chloride. Now light a matchstick and place it at the mouth of the test tube. Observation: you will hear a pop-up sound and find the flame get extinguished. Explanation here: the pop sound confirms the release of hydrogen gas. The flame get extinguished because hydrogen does not support combustion. The name of the salt has two parts. The first part is usually the name of the metal that displaces the hydrogen in the acid. The second part is the radical of the acid. Examples of some salts, that is sodium chloride. The formula is NaCl. Magnesium sulfate, formula is MgSO4. Ammonium nitrate, formula is NH4NO3. Properties of salts. Most of a solid salts have high melting and boiling point. Most salts are soluble in water. Although solid salts are electrically neutral and do not conduct electricity, their solution can conduct electricity. Uses of salts. Salts are very useful in our daily life. The uses of some salts are discussed here. Sodium chloride. Sodium chloride is the common salt used in food to enhance taste. It is good preservative and used in preserving pickles. It is also used for producing freezing mixture by adding it to the ice. It finds extensive use in the manufacturing of pulp and paper and in setting dyes in textiles and fabrics. It is also used for making soaps, detergents, and other cleaning agents. Sodium carbonate is also used in the manufacturing of glass. It is also known as washing soda because it is used for softening hard water and to enhance the capacity of detergent. Sodium bicarbonate are also known as baking soda, used for making baking cakes and breads. It is also used in some aerated drinks. It is also useful in the preparation of many medicines and even in the fire extinguisher. Neutralization reaction in everyday life. Neutralization reaction are quite common in everyday life. Insect sting. When an ant or bee sting us, it is painful and very irritable. This is because of secretion of formic acid from insect mouth. For relief, we can immediately apply baking soda, which is a base, on affected area. Baking soda neutralizes the acid and give instant relief. Wasp sting, on the other hand, is basic, so vinegar, that is acetic acid, is used for relief from wasp sting. Acidity. Excess hydrochloric acid in our stomach can cause indigestion and is painful. To treat such indigestion caused by acidity, antacid tablets such as milk of magnesia, that is magnesium hydroxide, are used to neutralize the excess acid. Treating waste from factories. When acidic waste from factories are disposed of in rivers, they are first treated with base to neutralize them. This prevents the river's water from getting acidic. An acidic substance may harm aquatic life. Preventing tooth decay. When you brush your teeth using a toothpaste which contain a base, any kind of acid present in the mouth or teeth cavities are neutralized. This help in preventing tooth decay. Treating soil. Most of the plants grow best in neutral soil, but excessive use of fertilizers makes the soil either acidic or basic. This affects the growth of plants, thereby affecting the productivity adversely. In such situation, neutralization reaction helps in the following ways. Acidic soil is treated with a base like slaked lime, that is calcium hydroxide, to neutralize the effect of the acid. Basic soils are neutralized by adding large quantities of acidic substances like compost manure. Thank you.